At lunch, one of your friends has a happy face and one of your friends has a sad face. The happy friend received a 60% on her biology test, and the sad friend received a 60% on her history test. How could they both receive the same score and have different reactions? What do you think? What do you think? They both got 60s, but one is happy and one is sad. Why could that be?
Because one didn't study, one studied.
Maybe. So one had like expectations of like doing better, and they studied and got 60, and one didn't study and got 60. Okay. That's a good one, actually. Okay, so if I told you that the mean of the biology test was 50 and the mean of the history test was 70, would that help explain their reactions? So basically, if the biology test, the class average was 50 and she got a 60, or for the history test, the class average was a 70 and she got a 60, would that make sense to why they're happy and sad? Yeah, because one is either happy that they got above the class average or one is sad they got below class average. Does that make sense? Okay, keep that in mind because that's what we're talking about today. Well, if you get the Z table tattooed to you, you don't really need it for the SOL because they give it to you in the SOL. But I like the idea. Okay, so turn to day 3, or wait, day 2, right? Alright, so this is all about Z-scores. So one more statistical measure we can use is called Z-score. You'll notice that whenever I write Z-score, I like to put a line between it because once you start putting numbers, I don't want you guys to get confused with like a 2 and a Z. And I'm seeing your handwriting, so I know how easily you guys can be confused. Alright, your formula for a Z-score is on your formula sheet. So you will have it on your SOL, you will have it on your final. Okay? The only thing that is new here is the Z is for Z-score, and the X is for raw score. That basically means like what's your data point. That's what raw score is. You know what that other symbol is? That's the mean. The last one is your standard deviation. Alright, so back to the girls who were just talking about. One's happy, one's sad because they both got 60%, but we don't really know why. But we do know that the class average for one test was 50 and the other class average was 70. So our Z-score could help you figure out who did better because the Z-score basically like levels it out. So letter C says for the bio test, the mean is 50 and the standard deviation is 10. Find the Z-score for your happy friend. Alright, so here's your formula. Z equals X minus the mean divided by your standard deviation. Write that down. So we're going to find the Z-score. What is my data point? What was the score that she got? She got a 60. It's not in this sentence, but we know that from the beginning. Alright, what's my mean? No. 50. My mean was 50. What's my standard deviation? Why are you saying 60?
For the C on here, 6.
You don't see where it says standard deviation is 10?
Oh.
Oh, you're on the wrong one?
Yeah.
Oh my god.
I was on A.
So for A and B, we didn't write anything. We kind of just skipped over it. Okay, we just talked about it. So turn to letter C. All right, let's work this out. 60 minus 50 is, guys, 10. And 10 divided by 10 is 1. So the happy friend, her Z-score is 1. Alright, and then it says for the history test, the mean is 70 and the standard deviation is 10. Find the Z-score for your sad friend. I have my formula. Z-score equals X minus the mean divided by standard deviation. What was the score for the history test? No. What was the score that that sad friend got? 60. It's not in this sentence, but we just know it. All right. And what is our mean? What was the class average?
70.
70. And what's my standard deviation? So what is 60 minus 70? And negative 10 divided by 10 is negative 1. So your happy friend has a z-score of 1. Your sad friend has a z-score of negative 1. So this explains why the happy friend is happy. Because you want your z-score to be higher than the other. So take a look at this. A positive z-score means the data point is above the mean. A negative z-score means the data point is below the mean. And the bigger the z-score, the further away the data point is from the mean. All right, so let's take a look at this. Remember that our formula is z-score equals x minus the mean divided by, okay, you don't have to write this over right now, just remember that. So it says, given the following information, find the missing value. And set up each equation and round to 2 decimal places. Look at number 1. What's my mean? 7. What's my standard deviation? 2. What's my data point? 11.5. They want us to find the z-score. So in order to find the z-score, I have my formula. Z equals, what's your x? 11.5 minus, what's the mean?
The U, right?
Yep. There it looks like a U, but I think it looks like an M sometimes. And what's my standard deviation?
2.
2. So I want you guys to put this in your calculator. You're going to do 11.5 minus 7 divided by 2. What do you get? What do you get? 2.25. So in your calculator area, do 11.5 minus 7, hit enter, and then divide by 2. You got it? All right. And look at number 2. They gave us the mean, which is 21. My standard deviation is 4. My z-score is negative 2.5. I need to find my x. So, what do they give us for z-score?
Negative 2.5.
Alright, so let's write that in. Negative 2.5. Instead of writing z equals, we're going to write negative 2.5 equals. I don't know what x is. What's my mean? 21. And that's going to be divided by my standard deviation, which is 4. Alright, how do I get rid of this? Wait, let's get rid of that fraction first. Times 4 on each side. And so that cancels out. I'm left with, what's 4 times negative 2.5? Negative what? No, 4 times negative 2.5?
4 times negative 2.5 is negative 10.
So we have negative 10 is equal to x minus 21. I want you guys to tell me what's x. Go ahead and solve for it. Alright, so when you add 21, add 21, you're left with x equals 11. Everyone got that, right? All right, so it says you can use z-scores in order to compare two sets of data. You want to find the z-score for each situation, and then whichever z-score is higher is the better situation as compared to the rest of the data. So far, so good? All right, so the thing about this lesson is that you guys cannot be afraid of word problems and you can't just skim through it, right? So if you need a highlighter, let me know. There's no one highlighter? If not, just underline it, okay? Here's what's important. The children of the Smith family were arguing at dinner as to who did better on their test at school. Sally earned a 90% on her spelling test. The average grade on the spelling test was 82%, and the standard deviation was 4. Okay, so that's one sibling. And then the other sibling, John, got an 85 on his algebra test. The average was 70, and the standard deviation was 5. They want to know, because they're arguing, who's right, who's wrong, who did better. I want you guys to write exactly what I'm writing, okay? So we have Sally, and we have John. All right, Sally. We're going to compare their z-scores because that's what levels the playing field. So we have z equals x minus the mean divided by standard deviation. I don't know her z-score, that's what we're solving for, to compare. What was her score on the test? What was her x?
90.
She got a 90. What was the class average? Minus 82. And what was her standard deviation?
4.
4. What did she get for its z-score? Type in the top part of your fraction, hit enter, then divide by 4. Her z-score should be 2. So now we go to John. Let's look at his z-score. X minus the mean divided by standard variation. What was his score on the test? 85. And what was the mean? 70. And the standard deviation was 5. And your calculators, I want you to type in 85 minus 70 divided by 5. 3. So, who did better on their test? Whose z-score is higher? John is higher, so therefore, tell her she's not special. So therefore, John did better.
The odds of 82, she got 90.
Somehow you guys have to tell me that you know that it was John. You can circle the answer, you can circle his name, you can write the sentence. I'm not really picky on it. As long as I go on your test or your quiz, I can tell. Now, I want you guys to do the next one. Let's read it together. All right, who is better at their sport as compared to the competition? LeBron James, who scores 27.1 points per game when the league average is 9.63 points per game and the standard deviation is 5.6, or Peyton Manning, who passes 342.3 yards per game when the league average is 235.6 yards per game and the standard deviation is 35.3. So we have LeBron James, who's 27.1, league average, standard deviation. And then we have Peyton Manning, who has 342.3 points or yards per game. The average was 235.6, and then your standard deviation. So I want you guys to compare LeBron's Z-score to Peyton Manning's Z-score. And I want you to tell me who is better in their own sport. You have 2 minutes. All right, so I'm going to put my answers up. You compare your answers with my answers. You guys get 3.12 for LeBron James?
Oh, yeah.
Z-score? Okay. You get 3.02 for Peyton Manning. So who's better at their sport? My favorite. Does that make sense?
Your favorite.
LeBron's my favorite athlete.
Okay.
My favorite NBA athlete. I don't know. I've liked him since I was like 8th grade. It's just so good.
In the Cleveland area. And then leaves to Miami, back to Cleveland.
Yeah, I didn't have a problem with it. Not after you like spend 7 years in one city, you can leave. That's how he left. He didn't have to do that whole special. All right, so this is where I need your focus. Okay. Besides determining a value's distance from the mean, a z-score is associated with probability. You'll hear me say that a lot today. Probability and percentile. Percentile just means when it says percentage, that kind of stuff. Once you have calculated a z-score, the table is used to indicate what percentage of the data is to the left of the z-score on the normal curve. And then you're going to round your z-scores to 2 decimal places. Okay, everyone grab your z-table. Your z-table is that blue sheet that I gave you. I know there's a lot of numbers, and the scary part is you can make like one small mistake and not really focus on what you're doing and get the wrong numbers. Okay, so on your packet, on your notes, okay, huh?
You're going too quick. I was going to explain this. You're going too quick.
For which one? We haven't even got there yet.
No?
No, it's right here. Or this one?
Yeah. So you record the next one.
All right, so it says given a z-score of negative 1.25. Okay, this is our z-score. Everyone look at your table. Turn to where you see the negative numbers on the left side. So I'm focused on this side. Wherever you see the negative numbers, that's what we want. Okay? So, you guys see how it says negative 1.25, right? You guys see how there's only 2 numbers though, right? There's like a 1 point something, like there's always a number, point, a number on the left side, right? So that means I want you guys to focus on what's the first 2 numbers in this number here?
First number?
Just negative 1.2, right? Okay, so on the left side, you're going to go down to negative 1.2. Put your finger there. That's why I got these rulers. If you guys want to use them. You don't have to use it, but it could help. Alright, so put your ruler right where you see negative 1.2. Okay, you guys there? Alright, so out of this number, negative 1.25, what am I missing? The 5. So that 5 is basically 0.05, because if I were to add this together, I get what my original number was. Okay? So this part was on the left side, this negative 1.2 was on the left. The rest of it, 0.05, will be on the top. So what you're going to do is you're going to put your ruler here, or your finger, or whatever you have at negative 1.2. On the very top, you're going to go find 0.05, and you're going to scroll down to where they meet. Does that make sense? I'll walk around for a second. Okay?
I did not know.
Definitely circle with your pencil, not with your pen, or you're going to end up having a million circles. Alright, so the value is 0.05 or 0.1056. Do you guys see that? Okay. I want you guys to write something on your blue paper. Write it at the bottom, write it at the top. I don't care, but write it somewhere. Your first note to yourself is that your Z table is all prob below. That is super important. You'll hear me talk about prob below, prob above, prob between. Okay? And prob just means probability. So everything in the Z table is below. Jeff, are you with me?
Yeah.
Alright. Your second note to yourself is to never round your probabilities. Or you can just write prob, doesn't matter. I like to abbreviate it. So you should always have 4 digits. Everything in your table is 4 digits, keep it that way. I don't want you to round any of it. The only thing you'll be rounding is if you get a Z-score. If you get a Z-score, you can round that to 2 places. You never round the 4-digit numbers. Okay? Isaac, I need you to write that on your blue sheet.
Oh.
Just transfer it later. Alright. This says, find the percentage of data that falls below the following Z-scores. This is going to require you guys to read what it's asking you to do. I will help you by underlining things that are important. So in this case, it's important to know they want the percentage, which I'll show you how to get that, and they want falls below. Definitely circle that. Alright, so look at your blue Z table. They're asking for negative 2.89. So that means I'm going to go to negative 2.8 on the left side. Use your ruler, use your finger. On the top, I'm looking for 0.09. That gives me a total of negative 2.89. So on the left side, you're looking for negative 2.8. At the top, you're looking for 0.09. All right, what are you guys getting?
0.0019.
Good. 0.0019. So notice how I write this. I always write what it is. The prob below is 0.0019. Sometimes they'll ask for the probability, but sometimes they'll ask for the percentage. If we want to go from a decimal to a percent, I move my decimal how many times? 2. Okay? So they ask for a percentage, not probability. So therefore, I'm going to move my decimal 2 times, and my answer is 0.19%. That is the percentage that your data will fall below the Z-score of negative 2.89. All right, look at number 2. On number 2, they gave us a Z-score of 3.21. So on the left side, you need 3.2. What do you need at the very top?
The one.
The 1. So we have 0.01 on top. If I add that, I get 3.21. You guys tell me, what is your prob below? So it's straight from your table. What'd you get, Eric? 0.9993. So I tell you guys to just make sure you double check, because I don't want you to do all this hard work and then you just look at the wrong number. But they want the percent, so how do I change 0.9993 to a percent? Yeah, let's move our decimal over 2 places. So we have 99.93%. I'm not sure why I did it this way. I should have just did probability first. You guys were used to it before we changed it, but we'll just go with it.
I got a quick question.
Well,
We get the 0.01.
because that's what's left over. We have the first 2 digits tell you how to find, like, what to look for on your left side. This last digit here tells you what to look for on the top. Okay. All right, so you can also find the probability of falling above a Z-score. We just did below. Everything in your table is below. So if you want to know how to find above, you need to do 1 minus your probability. Below. Oh, this board. Write that down. We're going to do 1 minus whatever probability you get. So what you have to do is make sure you read the directions here. Find the probability of falling above the following Z-scores. Okay? That's important. So look at number 3. This looks a little different, but what this really is negative 0.04. Same thing. It looks like negative 0.04, but you can just add that 0 in front. So on the left side of your Z table, what numbers are you looking for? What's the first 2 numbers here?
0 and 0.
Negative 0.0. That's what you're looking for on the left side of your Z table. These are normally the trickier ones. And then at the top of your Z table, you're looking for what number?
4.
Yep, 0.04. Okay, you guys let me know, what do you get for your probability below, which is straight from the table? What'd you get? 0.4840? Okay, but that's our prob below. They asked for the prob above, right? So for the probability above, we're going to do 1 minus 0.4840. What do you get? .516. Because they asked for probability, leave it just like that. All right, look at number 4. This Z-score, it looks like it's showing 2 numbers. The Z-score is really 2.89. 2.10. They just didn't add a 0 on the end because they didn't need it. So what two numbers do we look for on the left side? 2.1. What number do I look for on the top? Just 0. So we're left with 2.1. So you tell me, what is your problem below? For that number. 0.9821. So that's our problem below. If I want to find above, I'm going to do 1 minus 0.9821. What do you get when you do 1 minus 0.9821?
You get negative 9820.
I didn't get that.
I got positive 9.
You got what?
9822.
Did you do 1 minus 0.9821?
I want to put the decimal.
Oh yeah, put your decimal in. Yep, I got 0.0179. Alright, so a quick recap. If you want to find prob below, I look where?
Prob below.
Yeah.
Look on the next.
No, prob below is that whole table. Right? The whole table is prob below. How do I get prob above? You minus 1. Or you do 1 minus that.
So prob below, you look at the whole thing.
You look at the table. Whatever is in your table will be your prob below. Okay? The last one is prob between. So we can do the probability of finding something between another z-score. Okay? When you do prob between, you're going to do big minus the little. So your big number, your big probability minus your little probability. So your directions say find the probability, so keep it as a decimal, of falling between these two z-scores. So what we're going to do is we're going to find the prob below, because we have to start with prob below for both of these z-scores. I like to abbreviate it just so we know what's going on. Alright, so look in your table at for the z-score, negative 1.32. What's your prob below? Negative 1.32.
Negative 1.3, right?
Yep. What do you get for your, given your 4-digit probability? You guys should get 0.0934. Let me know if you didn't get that. You good, Jeffrey?
Yeah.
What about for 2.43? Positive 2.43.
I'm confused how she got that number.
I can't hear you.
Oh, you're
I'm confused how she got that number. I couldn't find it on.
2.31.
Yeah.
So, Isaac, did you go to the negative 1.3 on the left side?
On the left side, just wait. That that's this side.
On the left side, do you see negative 1.3?
Is it 0.9?
That is right, yes.
So I don't see that one point.
Alright, you're gonna have to wait a second, Isaac. Alright, so
Never mind, I see it.
what we have to do here, because they're asking for prob between, I need to subtract the big number, so 0.9925, and then minus 0.0934. What do you get for your probability? Subtract those two numbers. 0.8991, right? Good. All right, you guys do number 6. Good. Jeremy, are you getting this? My part below for number 6 for negative 2.76 was 0.0029. The part below for 0.43 was 0.6664. So then Chenny did 0.6664 minus 0.0029, and your answer was 0.6635. Any questions there? Okay, so we have to stop there because we don't have time. We'll do the examples next time.